Swayam Prabha. Digital India. Educated India.
Good morning. Welcome to the fourth lecture of this week 6 of this ongoing course on understanding and reducing greenhouse gas emissions. We are specifically looking at the contribution of building design and construction towards GHG emissions and the reduction for scope 1 and 2 emissions. In today's lecture, we are going to look at natural ventilation and mechanical ventilation in buildings, and we will see strategies how to reduce the energy consumption when we are attempting natural ventilation. In the previous lecture, we looked at some of the advanced passive design strategies. Some of these strategies also talked about natural ventilation, but mostly the strategies that we have seen in the yesterday's lecture and the lecture before that, where we talked about passive design strategies, is about maintaining a thermally comfortable environment, and we had less focus on the air speed, the air movement inside the buildings. In today's lecture, we are going to focus on different types of natural ventilation which can take place in the building, the passive ventilation, types of ventilation systems, the mechanical ventilation. So, we are largely going to focus our discussion on different ventilation strategies that can be employed in the building. So, when we look at the different types of natural ventilation that can happen inside the building, so we are looking at cross ventilation, and we have seen in the previous lectures how that can be facilitated. So, we are looking at provision of fenestration, it could be doors or windows or ventilators on opposite or adjacent walls. And in case we have opening only on one facade, then we are looking at single sided ventilation, in that the same window, the same fenestration, when we are looking at a wall section. So, we are looking at the same fenestration acting as an inlet as well as an outlet, and thereby reducing the circulation of air within the space. While in cross ventilation, we are actually looking at the ventilation through the entire space, and in case we have fenestrations which are provided on different levels. So, in walls as well as roofs, then we are talking about stack ventilation. This effect can be enhanced with the help of strategies such as what we have seen yesterday, which is wind towers. So, in case the second opening, which is in a different element, it is enhanced. Here the stack effect is further pronounced. So, if we are providing fenestration at different levels is what the third type of natural ventilation which will happen. When we say different types of natural ventilation, we are thereby meaning how the air circulates within the room. So, that is the typology we are talking about. So, this one is stack ventilation. Now, with this understanding, let us look at some of the strategies of passive ventilations. A lot of these strategies may seem very simple, but unfortunately, we are not employing them in our buildings, especially the commercial buildings, the office buildings. In residential buildings, since it is single ownership, individuals are responsible for the energy consumption and also for paying the bills. So, a lot of these strategies are employed in residential buildings, but the moment we are talking about commercial buildings, the offices, we are not employing these strategies. So, today we are going to quickly look at the operable windows, buffer spaces and double facades. Building shape, space planning and orientation is something that we have already seen in the second lecture of this week. We will quickly go through it over again, how it aids in facilitating natural ventilation. Then strategic architectural features, openings into corridors, central atrium. This also we have seen when we were discussing about courtyard and how it facilitates the ventilation. It kind of induces the ventilation in the building, and wind towers also we have seen. Now, the first and the most important element which facilitates natural ventilation is windows and shades. Now, when we say windows and shades, so windows facilitate two things, one ventilation and second daylighting. Now, here we are focusing on ventilation. Shades also help us to control this lighting, the amount of light and ventilation that can be facilitated through the window. Now, what is happening in today's times is that more and more of these commercial buildings, because they are centrally air conditioned, and for operational limitations where they cannot be providing operational controls to individuals, manual controls are restricted, and hence we would find that in majority of the commercial buildings the windows are sealed, they are not openable, they are closed windows, despite the fact that 60% of the time in our country the temperatures remain between thermally comfortable range. Despite that, we are not able to bring in the air from outdoors to the indoors. There are other reasons for that, the level of pollution, the level of particulate matter in the air is also restricting us to open the windows. But even where the possibility is there, the operable windows in commercial spaces are not being provided. Now, we are talking about allowing that as the first strategy to enhance comfort. But of course, the moment we say that, we also have to see that there has to be an integrated system where the system senses, identifies, or if manual controls are being provided, the air conditioning system is automatically stopped and only natural plus mechanical ventilation is provided. Now, this will happen only in case the thermally comfortable environment outdoor prevails. So, we have to provide windows which are openable in buildings, if not all, then strategically some windows have to be provided which can be opened manually, and manual overrides have to be provided over the program that has been provided for operations. The second thing is shades. Now, shades as we are seeing here are the blinds which are the internal shades most of the time. So, we can close those shades or we could open those shades. We are also talking about the permanent shading devices which we have seen in the passive design features. We have to design these window shades in order to cut down the sun when it is not needed, still allowing for the daylight to be passed inside the building. The second thing we are talking about when we say natural ventilation has to be enhanced is the building shape. So, as we have seen, how and where these windows fenestration are being provided determines how much area is likely to remain naturally ventilated. So, if we can see here, this is slight stack effect in place here. So, the opening is provided in the direction of the wind and this acts as the inlet and the outlets are two. So, what is going to practically happen is that the hot air is going to rise up and is going to exit through the higher fenestration, while the cooler air, the relatively cooler air is going to exit. Now, this is absolutely dependent upon the direction of the wind, predominant direction of the wind. What if the wind, the prevailing wind direction is this? What happens in this case? In this case, the wind will also enter from this fenestration which is provided at the top, and in that case the hot air will not be able to escape as comfortably as we are seeing in this configuration. So, what we see here is that the placement of window with respect to the building shape and the placement of window with respect to the wind's direction becomes extremely critical, crucial. We have seen earlier, suppose we have fenestration which has been provided on two opposite ends. Now, if we are looking at the windward direction, if it is like this at 45 degrees or perpendicular to the wind direction, it works. So, this is how the movement of wind is going to happen and the remaining area getting eddies of the ventilation. However, if we provide the window in a manner that it is parallel to the direction of wind, there will be very small amount of ventilation that will take place and there will only be small eddies forming in the in a small area which is just close to the windows, and rest of the room is not going to have any ventilation happening. So, building shape and then placement of fenestration depending upon the wind's direction is what we are going to look at when we want to provide for natural ventilation. We have already seen the space planning and orientation, vegetation and buildings, they shadow each other, they create negative spaces as far as natural ventilation is concerned, they create shaded spaces where we will not receive wind. For example, if we look at this particular diagram where 4 buildings have been provided. Now, if this is the prevailing wind direction, we are not going to have any wind here. So, this surface of the second building is not going to get any wind despite being perpendicular to the windward direction. So, we have to see how these shaded areas, how these shadow areas are going to get created. Preferably, the fundamental should remain that if we have to provide a window for natural ventilation, then it has to be between 45 to 90 degree of the windward direction. So, if this is the windward direction, at max we can provide a window which is up to 45 degrees of that angle. Anything beyond that will not help in natural ventilation. Next, we are talking about openings to corridors. Now, corridors can act as facilitators provided their ends are treated well. Now, what happens? For example, in this case, if we have enclosed ends and there is no possibility of ventilation of this corridor from both the ends, then this corridor will not aid in natural ventilation. However, if we have here in this case they have provided a staircase at the end of the corridor, both the sides they provide. Now, this staircase is going to have a continuous shaft. The staircase is going to remain open provided we do not have a fire door here which remains closed all the time. If this door remains open, in that case this stack, this staircase tower which is going to be there will act as a wind tower, and all we have to do is to the top of it we increase the story, the height by another story, which at least one story we already have, one more story, and we provide exit for the wind. So, what we are looking at here is, suppose these are the different floors that we are talking about, say this is a section through the corridor, and then towards the end we have this staircase which is running, and we have one more story, and towards the top we create these vents. They can be provided with mechanical exhausts which run. Now, each of this corridor is going to exhaust the air through these vents is what we are talking about, and the windows which have been provided in these rooms will act as inlets. Now, in which direction would we provide that? So, we are talking about say 45 degrees to the prevailing wind direction, or preferably perpendicular, but in that case what we are seeing is that we will have this side as a shaded area. We will not have wind coming into this side, but what will happen if we forced ventilate this corridor, since there is negative pressure here, but in that case we are also recommending to open these doors, there has to be opening so that there is circulation, and when there is negative pressure there will be air which will be drawn into the room from the opposite side even when it is a shadow area. So, corridors can facilitate, but their ends have to be treated well. Preferably this is the best arrangement that we can have, where we have a tower towards the end and it exhausts the air from the corridor, from each corridor, and thereby allowing the windows to draw in more air. So, this is a simple strategy or design strategy, but it facilitates natural ventilation. Wind towers and wind catchers, we have already seen how it works both ways. It can act as an exhaust or it could act as a supplier, and if we add the sprays, water sprays into that, it becomes a down draught and it will further aid in cooling, which is what you must have seen in case of traditional desert architecture, the arid, semi-arid architecture, the Middle East architecture. The central atrium, the courtyard, it could be open to sky or may not be open to sky, also aids in that. Also, what we plant here in the bottom will determine how much of ventilation is going to happen through that. Now, we also have to see that there are multiple factors which will affect this. If you remember yesterday's discussion, we were talking about thermal mass on both the sides and the courtyard in the center. Now, we were assuming only 2 stories and then there was a courtyard. Now, assuming a case like this where there are multiple stories, there is, except for the noon time when the sun is absolutely on our heads, this courtyard is not going to receive much sun. So, there is no point providing a hard surface because it is not going to get heated up enough through the solar radiation. So, what we will have here is that we can actually have vegetation, a green cover here. Now, what will that green cover facilitate? It will maintain the environment as cooler, and what it will do is that in general it will allow the air, warmer air to escape. So, ventilators of each side will help in drawing air out because this top level is going to be hotter than the bottom layers. So, in general the courtyard or the atrium is going to help in exhausting the air at upper levels, while at the bottom ones the vegetation is going to help in creating a more comfortable microclimate, a climate which is microclimate which is at a lower temperature. So, this is how atriums will aid and facilitate. In addition, we are not discussing about daylighting here, but these strategies, most of these strategies will also help in bringing in some daylight. So, we will also have to weigh the benefits that are coming from reduction of requirement of energy for artificial lighting. Then we have also seen the role of vegetation in the previous lecture, re-emphasizing it again for natural ventilation. The height of vegetation and the placement of vegetation affects the natural ventilation inside the building significantly. So, if we have trees which are right at the level where the window is, then we are going to have the ventilation which is significantly reduced, while if we have trees which are slightly higher, their canopies are higher than the window level, in that case the air will be cooler underneath the trees and it will help in natural ventilation and of air which is slightly cooler than the ambient air temperature. So, the size of the tree that is to be provided, vegetation that has to be provided, and also the proximity of it to the building is going to determine how much of shadow for wind is going to be created and how much of ventilation is going to be facilitated. Now, when we these are passive design strategies that we are talking about, but now when we talk about commercial buildings, if you are working with corporate offices and if you are looking at their offices, you would think that practically it is impossible to have only natural ventilation in the building, because we will require, we are situated in bigger cities and it is a huge office and less possibility for natural ventilation. Even if it is there, it is impossible to maintain comfortable environment without mechanical ventilation. Yes, mechanical ventilation will have to be provided, but what we are saying is that natural ventilation should not be cut off entirely, or both can be provided to reinforce each other. Now, in a lot of cases what we would see that it is only mechanical ventilation through the ducts, through the air tubes that we provide, and there is no possibility. So, what we can actually do is we can have both natural ventilation as well as mechanical ventilation. So, in case what we have seen, I am not even talking about air conditioning here, I am only talking about ventilation. So, what we have seen in case of wind tower, we allowed the air to come in through the windows at lower level and the exhaust is there through the wind tower where mechanical exhaust has been provided. Now, what is this? This is supply is natural and the exhaust is mechanical. So, we are exhausting mechanically and drawing in naturally. We can also have natural where there is wind tower, and we provide the wind tower in such a manner that natural wind, the wind which is there naturally, it is drawing the air out, it is exhausting. So, it could be both natural, it could be the other way around, here mechanical and natural. For example, we can have earth air duct here, earth air tunnel here, and we might be providing a pump, a fan, which will help us in drawing the air through that earth air duct mechanically, and it will be exhausted through the tower, probably the staircase duct naturally. So, that could also be a possibility. We can have multiple scenarios, and what we are normally doing here is mechanical and mechanical. A lot of times we are supplying the air mechanically and exhausting the air also mechanically. What we have to aim is the energy is going to increase linearly like this. What we have to try doing is a system which is both natural and natural. It could be seasonal, it could be diurnal, that sometimes of the day we need to add mechanical ventilation. In certain seasons we might be needing more mechanical ventilation, while in comfortable seasons we may not be needing mechanical ventilation at all. So, it is going to be a mix of that. So, particularly in case of India, we are a tropical country and predominantly a warm country, large geographic area of our country, and throughout the year, for large time of the year, remains comfortable, and we can open the windows. So, there we have to try to have mixed mode, where we have HVAC, we also have mechanical ventilation, but we also have the possibility for natural ventilation. Now, when we are talking about ventilation systems, we can also have advanced measures such as energy recovery. Now, this could be, so what does energy recovery implies? That if we have, specifically in case of air conditioned buildings, where we are either cooling or heating the air. So, if the outdoor air is slightly warmer and the indoor air is maintained at a lower temperature, in that case when we are exhausting the air, this exhaust, for example, these are the two ducts. So, this is the exhaust duct and this is the supply duct. Now, the supply air is going to come at say 35 degree centigrade from outside. So, this is a warmer air which is going to be sent to AHU here, and then it is treated, and after that it is supplied into the space, and from the space it is going to be sent to exhaust. Now, this might be at 35 degrees when it is going to be sent to AHU, the HVAC plant, and when it is exhausted from the space. So, when it is supplied into the space, it is probably at 15 degrees or 12 degrees or 18 degrees, but even when it is leaving the space, it is being exhausted out, it is only at 25 degrees centigrade or 23 degrees centigrade. There is still a difference of 10 degrees here. So, what we will do is that we will have an energy recovery. So, the air is not mixing, but the heat from this cool air, which is the exhaust air, higher in carbon dioxide, will take the heat from this air which is at 35 degrees. So, while exhausting, the coolth of this is exchanged between the air, and this is what is energy recovery. And by the time this air at 35 degrees, the outdoor air, is supplied into the AHU, it is already say 30 degrees. If we look at, if we are able to do a most efficient energy recovery, then this will be already cooled down, it will be pre-cooled by 5 degrees, thereby saving a lot of energy to the HVAC system. So, such mechanical systems are available which should be used when we are going for mechanical ventilation in addition to the natural ventilation. With this, I will stop here. There are many more mechanical systems which are energy efficient, which have to be employed in the buildings, which we will talk about later. But the first step towards designing efficient buildings have to be naturally ventilated. These buildings have to be naturally ventilated. With this understanding, we will move on to daylighting in the next lecture, the last lecture of this week tomorrow. Thank you very much for joining me. Bye-bye.